Developer Mode in ChatGPT5. Executive Summary. Developer Mode in GPT-5 offers developers transparency, structured outputs, reasoning traces, and fine-grained controls. It enables experimentation, debugging, and scalability with metrics and sandbox testing. While boosting innovation and reliability, it raises challenges in safety, complexity, and ethics. Ultimately, it transforms GPT-5 into a programmable AI development platform. Article: With the arrival of GPT-5, OpenAI has moved beyond merely producing a more advanced conversational model. The emphasis has shifted toward expanding the flexibility, transparency, and control available to developers who build on top of the system. Among the most notable additions is Developer Mode, a set of tools, configurations, and operational behaviors that empower technical users to push GPT-5 beyond standard conversational use. This essay explores Developer Mode in GPT-5, its objectives, capabilities, applications, benefits, and the challenges it introduces. What is Developer Mode? Developer Mode is not a separate version of GPT-5, but rather a configuration layer that allows deeper customization of the model's behavior, visibility into its reasoning process, and access to fine-tuned performance metrics. In practice, Developer Mode bridges the gap between using GPT-5 as a black box chatbot and wielding it as a programmable engine. Key aspects include debugging capabilities for prompt chains and API calls, extended output formats, JSON schemas, structured reasoning, multimodal embeddings, sandbox experimentation, with relaxed safety filters for controlled environments, performance tuning through token-level insights, latency metrics, and error handling logs. Objectives of Developer Mode. Developer Mode was designed around 4 core objectives. 1. Transparency. Provide developers with more visibility into how GPT-5 interprets prompts, generates responses, and handles ambiguity. 2. Experimentation. Allow technical users to prototype unconventional applications, such as autonomous agents, simulation systems, or complex multi-step reasoning pipelines, without being restricted by consumer-facing safeguards. 3. Customization. Enable deeper tailoring of GPT-5's outputs, including tone, verbosity, knowledge prioritization, and even the integration of custom retrieval plugins. 4. Diagnostics and reliability. Give builders tools to identify bottlenecks, test fail-safes, and understand how GPT-5 scales under production-level load. Core features of Developer Mode. 1. Structured outputs. Developer Mode allows developers to enforce schemas on GPT-5's responses. For example, a developer can instruct the model to always return a JSON object with specific fields. This ensures predictable and machine-readable outputs, critical when GPT-5 is embedded into larger systems. 2. Reasoning traces. Safe introspection. While GPT-5 does not expose its full private chain of thought, Developer Mode offers reasoning traces, structured summaries of decision pathways, confidence levels, and ambiguity flags. This gives insight into why a model produced a given answer without exposing raw hidden states. 3. Safety sandbox. One of the most debated features, the sandbox permits relaxed moderation in controlled developer environments. This means researchers can observe how GPT-5 might respond in edge cases, such as offensive prompts or adversarial attacks, without risking harm in public-facing applications. 4. Fine-grained controls. Developer Mode introduces parameters beyond temperature and top P. Examples include verbosity scaling, short summary versus detailed essay. Domain prioritization, e.g., prioritize programming accuracy over creativity. Latency versus accuracy balancing for time-sensitive applications. 5. Metrics and logging. Developers gain access to real-time diagnostics, token per second throughput, latency breakdowns, network versus generation, error rate tracking across batch requests. These metrics are crucial for production teams integrating GPT-5 at scale. Applications of developer mode: 1. AI research and safety testing. Academics and AI safety researchers can stress test GPT-5 in the sandbox to explore failure cases, jailbreak attempts, and bias propagation. This controlled visibility supports building more resilient alignment strategies. 2. Software development. Teams building AI copilots, debuggers, or test generation tools rely heavily on structured outputs. Developer mode ensures GPT-5 produces responses that integrate seamlessly with IDES, CI/CD pipelines, and static analysis systems. 3. Enterprise integrations. Large organizations using GPT-5 for internal analytics or customer support need predictable performance. Developer mode's metrics help them optimize infrastructure costs while ensuring service-level reliability. 4. Creative and simulation work. Game developers, storytellers, and simulation designers leverage developer mode to fine-tune world-building engines. By relaxing safety limits in private environments, they can simulate realistic characters, dialogue, and scenarios that wouldn't be suitable in a consumer setting. 5. Educational tools. Educators and education tech startups can adjust reasoning verbosity. For beginners, GPT-5 might output step-by-step math explanations. For experts, it can provide concise final answers. Benefits: 1. Predictability. Structured outputs reduce ambiguity and make GPT-5 more reliable in pipelines. 2. Visibility. Reasoning traces offer insights without compromising safety, enabling better debugging. 3. Flexibility. Developers can toggle between creativity and precision depending on the application. 4. Scalability. Metrics empower teams to measure and optimize GPT-5's cost and performance at scale. 5. Innovation catalyst. By lowering barriers to experimentation, developer mode fosters entirely new classes of applications. Challenges and risks. While developer mode expands possibilities, it also introduces challenges: safety versus freedom. Relaxed moderation in sandbox mode risks misuse if not properly contained. Complexity. New parameters and configurations can overwhelm beginners, creating steep learning curves. Resource intensity. Logging and detailed tracing increase compute costs. Ethical questions. Allowing developers to probe deeper into model behavior raises questions about privacy, alignment, and potential exploitation. OpenAI mitigates these risks through tiered access, strong API governance, and audit logs for developer mode sessions. The future of developer mode. Developer mode in GPT-5 is a first iteration. Future directions may include custom memory injection, letting developers preload knowledge or context modules, policy overlays, user-defined moderation layers that complement OpenAI's defaults, distributed reasoning, tools for chaining multiple GPT-5 instances with specialized roles, adaptive tuning, automatic adjustment of parameters, verbosity, creativity, based on user interaction style. As AI evolves, developer mode is poised to become not just a debugging utility, but the primary interface for programming with language models. Conclusion. Developer mode in GPT-5 represents a paradigm shift. Instead of treating large language models as sealed conversational agents, it reframes them as programmable reasoning engines with adjustable transparency, structure, and diagnostic tools. By offering structured outputs, reasoning traces, sandbox experimentation, fine-grained controls, and robust metrics, Developer Mode opens the door to more ambitious, reliable, and innovative applications. At the same time, the feature brings new responsibilities, balancing freedom with safety, managing complexity, and addressing ethical implications. For developers, researchers, and enterprises alike, Developer Mode is not just a convenience. It is a powerful framework that transforms GPT-5 from a conversational partner into a true AI development platform.